right, so this is sort of an abbreviated version of the talk that I've given a few times. So I'm just going to lightly touch on a lot of overview and tell some stories along the way here. My opening slide, I like to have some sort of story behind the title slide here. So this is Tesla's factory from a few years ago. If you remember, they had a whole bunch of automation problems. They've solved them somewhat, but general, their goal was all about automation, automate everything, right? So now they have some people in the mix, but still, it's a good balance. Oh, my clicker's not working here, and I called it a clicker. All right, so I'm going to talk about some of the whys and hows of why we test. And like I said, as I go through, I'm going to tell some stories about some of the things from my past and experience, and I'm sure a lot of you could tell similar tales from your backgrounds too. So I originally wrote this talk like I said, a few years ago. I started working at a multi-billion-dollar company. And before that, I had worked at a small shop, and everyone, had a heavy testing focus, right? So, and if you didn't add tests to your pull request, your code review would likely fail. So, as I switched jobs, I was a bit shocked to find out there was basically 0 tests on the project that I'd be working on. And to make it worse, the configuration files needed to get the project up and running were checked in. But they didn't actually match the development and the production environments either. So there was just some stale code all around. So, this meant it was next to impossible for me to do any sort of manual testing, because just getting the app up and running was a huge challenge. So I had to, bug other developers. I had to, get them to help me verify the configuration, and, have them, basically look over all the changes that I was making as I was making them. It was a total productivity downer. So if there was tests, for this application, this probably would not have happened, right? I could have been more productive. Maybe specifically in my case, if there was some sort of integration test that verified, the application had started successfully or something, I could have moved on and done something else. So most of us have seen charts that look like this, right? Basically shows, the earlier you find a bug, the cheaper it is to fix it. This is sort of old news. And if you find, a problem with your requirements, if you don't find that problem until you go to production, you're going to have a bad day, right? But I think this slide really points out more of a when and not a why. So why do we test? Right? So we test to prove the intent of our software. To prove it works to other people, to catch regressions, and tests serve as documentation for existing functionality. But I think more importantly, it's all about confidence, right? We test to provide confidence. Confidence our code works, confidence the application will not crash, confidence that the code change I'm making doesn't affect performance. It's this confidence that speeds up the development cycle, right? So as I talked earlier, I had no confidence the application I was working on would function as intended. And as the result, I had to go manually hit web pages and troll through log files, and some sort of test would have given me, like a green light. And again, I could have moved on to something else with confidence that I fixed an issue. So this is just the tip of the iceberg. There are many different types of things to test, different ways to test. And I'm going to touch on a couple of these as we go through here. And again, add some anecdotes as we go through. So first up is manual testing, right? So we all think that, we should end manual testing and, automate everything. And to be honest, I think that is a wonderful goal. However, manual testing is still good, right? There are a few things that manual testing can do for us that, automated testing can't. For example, usability. It's really hard to get a computer to verify if something is usable or not, right? However, it's really easy for a computer to tell me if a UI or workflow has changed since the last time that it was manually tested, and maybe that triggers some sort of manual testing process I have, right? You probably wouldn't want to automate some UI that's constantly, some new UI that's constantly changing, you want to manually review that first. Though, ideally, obviously, anytime you make any kind of UI change, adding tests is trivial. So you've already done that, but, that's not normally the case. And lastly, moving to automated testing, it also frees up time to do manual exploratory testing. So instead of repeating the same script over and over again, you have actual testing to go poke at various parts of your application, and find new bugs, as opposed to walking, the happy path over and over again. So I think unit tests are probably by and far, the most important type of testing we can do. The problem is, I think we often do them wrong. Many of us probably have seen unit tests that connect to some sort of database, right? Or at least in the Java world, we depend on Spring, or maybe in your language, you depend on some sort of dependency injection container, where it spins up half the application just to test a single method, and then maybe shuts the thing down again, and then rinse and repeat, 1,000 times. So, are you connecting to REST APIs during your unit tests, right? So those are all sort of indications that they're not really unit tests. So one of the quick things I do, to see if this is a unit test is, will it work when I'm sitting on an airplane? Now, that's not the only thing to check, but that's sort of level one of, if this won't work when I'm on a plane, it's probably not a unit test. And I feel like I still need to point this out, but it's the developer's responsibility to write tests. I've heard this at multiple times in conferences where people come up to me after the fact, and they mention that my developers won't write unit tests because they say I'm not a tester. And I'm still amazed that that opinion is out there. I've definitely heard that at the beginning of my career. But that's a cultural issue in your company. If you need to get past that before you can really make a dent in doing any sort of automated testing. So everything can be tested, and if it can't, it's probably bad code, right? So good unit tests force us to write more modular, less coupled code, because testing well-structured code is easier. But so what's a test? I like to say focus on the complicated parts instead of the trivial things. If your language has, getters, getters and setters, or field accessors, maybe that's not something you need to spend your test time focused on, but your actual, complex code probably needs a lot more tests. Now, ideally, if you can cover all of that, great, but, given time constraints, test the complicated bits first. And when maintaining your code, obviously, anytime you fix a bug, you want to add a test, right? So better yet, you write a test that fails to verify the problem, and then you fix it, and then you're good to go. I'm a big test-driven development fan, but I still don't always write my tests first. Sometimes I do. It really depends, how I found the issue or what I think of it. But I almost always write a test. Another key thing about unit tests is making sure they're fast to run. So as soon as your build takes longer than a few minutes, you start losing time to Twitter or Facebook or YouTube or whatever, or maybe even your work email. So you need to be able to run, a single unit test through your IDE without jumping through hoops. I've worked at a lot of places where, you could edit your code through your IDE or whatever editor you wanted, but then you had to jump to the command line to start the test and then attach a debugger to it. All of those things are a waste of time, right? So keeping your development fast, right? Click of a button, I can debug or run my tests, means you can get more done faster. And we still come across people that are afraid to refactor the code they're working on, right? That's usually a giant indication of you don't have enough tests, right? And without refactoring, your code will rot. So refactoring is not something we set time aside for. You don't need permission from your manager. It is something you do all the time. And when you're fixing a bug or adding a feature, you're always refactoring. And that means tests are critical here because they verify that your public APIs are still working. This means you can refactor all the internals you want, worry-free, knowing that your public API is working. Then we have these things called component tests. So I used to do this a lot. I mentioned before, I used to use my dependency injection to deal with all my testing. And this was a result actually of using field injection, which in the Java world is pretty bad. So it forces you to write code around your fields. So whether you're adding extra constructors or getters and setters, or anyway, the basic gist is I had to add a whole bunch of code that wasn't actually needed at runtime, but was needed just so I could expose things for my tests. The plus side was the tests were really easy to write. The downside was, you start losing control over your objects. It makes it a little harder to mock objects. The code isn't as isolated as it could be. And of course, they're slow. So that's not to say they're always bad, right? You do want to test that layer of your code. If you're using a dependency injection, you want to make sure that stuff works, right? Maybe you just don't need to test your whole application that way. So a while back, I wrote a whole pile of tests for some complicated LDAP logic. Now, if you've ever dealt with LDAP, you know that everybody does LDAP differently, right? So the code that I had would spin up an in-memory LDAP server. It was Apache DS, which is a great little project. And it would verify that our code basically returned the same results across a variety of different schemas. And anytime we found a new schema, we would just add another set of tests and it worked. So obviously, every time we found a new schema, our test took longer to run. So this, I apologize, this x-axis here is not actually to scale, but hopefully you can get the point I'm trying to make here. So my tests were slow because, like I said, I was spinning up a whole application. So let's assume for a minute that an hourly rate for a developer is $100 an hour, which is low, but 100 is a really easy number to talk about. And my tests take about 25 minutes to run, right? So this means that one test run costs me about 40 bucks to run, or cost my company 40 bucks to run or so, right? Now, you can extrapolate that out a little bit. Say I run my tests 5 times a day, 5 days a week, and about 50 weeks a year. Again, nice, easy math. So that ends up being about $200 per day to run my tests, right? Where I'm just sitting there waiting. Maybe I'm checking my email, but more likely I'm probably on YouTube or something. So $200 a day, $1,000 a week, or 50 grand a year, right? So cutting about 5 minutes off your test run, so maybe I shrink that down to 20 minutes instead of 5 minutes. So it could save me almost 10 grand a year. Right, so this data is a little fictitious, right? They're sort of based on real numbers. You probably don't run everything 5 times a day, 5 days a week, 50 weeks a year. But points have been proven on the internet with way less data than this. So take it with a grain of salt. And I do want to point out, I'm not suggesting you just refactor and rewrite all your tests, so they don't spin up your containers or whatever it is. This might be something you can throw hardware at. Right, so maybe you buy your developer a new laptop every couple of years, and if that cuts a few minutes off your builds, you've probably saved money within the first quarter. So you spend $3 grand every couple of years, you've earned your money back in the first quarter, and your developer's happy. So it's really a win-win. I also used to write really sloppy tests, which I'm not proud of, but it's a thing I did, and I'm in recovery now. So it's not to say they weren't effective, right? But they were hard to read. My previous opinion was, the testing code really wasn't important. I could just breeze through the code and not worry about things like closing file handles. We weren't running tests on Windows, so it didn't really matter, but just general code smells. And what I learned was, you spend quite a bit of time in your test code, often with large breaks in between. So, often you don't remember what the test code was supposed to do, or you're debugging someone else's test code. So it becomes important to keep the code quality of your test code good as well. Add comments, the normal testing, normal code health. Next up, I want to talk about integration tests. So this is a bit of a loose term, and as I mentioned before, this is often what we get when we talk about unit tests. You spin up your whole app and test some small portion of it. So I'm going to define an integration test as a test that has some sort of external dependency, right? A database, a REST API, or whatever. And because of this, they're often fragile, right? And it's just a fact of life. You have to get used to it. But your ITs should be testing some sort of high level functionality like REST calls, web pages, or whatever, and verifying the results. So you're probably not going to be too concerned that, you know, a specific add user method was called when you're testing when you're running an integration test, but you may want to verify that, you know, if I'm adding a user, that some user was persisted in a database or somewhere. Functional testing is a little different, and depending on who you talk to, you'll get a different answer. So I hear that the Ruby on Rails folks describe functional testing as sort of one layer above unit testing, but for the sake of this talk, I'm going to say it's black box integration testing. Right, so you don't care at all about the implementation, you just care about the user facing portion. All right, so if we go back to our add user example, so maybe you're just, you know, creating a user based on some REST service, and you're making sure the result you get back is good. Maybe you even go, you know, make another request to get the user to make sure it was still there. The actual implementation on the back end might actually just save things to memory, right? Which would be bad if you ever wanted to do something crazy like restart your app. But we have other tests at a lower level to test that, and we're confident that that's not the case. Then there's non-functional testing. And this is a huge catch-all term, and we could run a whole series of talks on each one of these topics. But I'm just going to touch on a couple of them. So first up is quality. So if anyone is super into metrics, you know, I want to point out the need for running your metrics during your builds. So back at that billion-dollar company, we used to run Sonar to collect quality metrics at least once a week on each project. And we had a whole bunch of projects. The problem was, unless you went looking for that data, it was useless, right? And only a couple teams did. So, you know, we spent a lot of CPU cycles, which, you know, are dollars, and a lot of time maintaining that infrastructure, and it wasn't actually getting used. So this means this type of thing needs to fall into the automation camp. Your build process should automatically fail when your code quality drops. Otherwise, it gets ignored, right? The specific metrics that you're tracking are actually less important, and the delta between, you know, the sort of the norm and what changes from a pull request or new code is what is important. You know, and sometimes, you know, if the metrics change, it's not always a bad thing, right? Say I add a complex algorithm, right? So my overall complexity goes down, but, you know, the reviewer should see that the metric for the complexity goes up, but they've also seen maybe that I've added a whole pile of tests, and the overall coverage for my change is actually really good. So you know, there's more context to make smart decisions on. At one point, I actually worked at a place that was trying to correlate developer commit, like line count, to test failures, and those aren't related metrics. So you're going to make sure that you're keeping track of metrics that matter. And I actually left that company because I didn't like it. So the code coverage cult. So I'm only half joking here. I think, again, test coverage is super important. I just don't think the absolute numbers are important, right? So the problem is, if I tell you that 80% coverage is good, that means 90% coverage is great, and 100% means my project is amazing, right? But that's not really the case. I've seen projects that fail, you know, with 100% code coverage. You know, that one application in particular fell over its first day going live and had to be rolled back, and it was a bad time. So my point I'm trying to make is, you know, there's more important things to do and test than just trying to focus on line coverage, right? So maybe in this failing application, maybe they needed to do some performance testing or verify things were working in a you know, a multi-cluster environment, or who knows what. I forget the details. It was many moons ago. So of course, you're probably not concerned with every single line of your code, right? If you have some common error handling logic, do you care about every catch block in your code? Maybe not, right? Maybe you do. Depends on your language and how things are structured. Your applications are different than mine, but I think the overall goal is you aim for high test coverage, but you should be more concerned with good quality tests. So for example, this slide here, we have a single method with a single line, right? It's trivial to get 100% line coverage on this, but you can see some potential problems right away, right? So what if cult is null? What if user is null? What if the name is empty? Are there any types of limits on the name? Is there any types of limits are there limits on the number of users we can add to this cult? Can the username have emojis in it? I mean, there's a lot of other things we can focus on rather than just focusing on metrics. All right, so a couple more slides. I'm running low on time here. So, another question I hear often is what type of testing should I use, right? And it depends on your situation, right? So if you're adding a bug, if you're fixing a bug, we add bugs all the time though. If you're fixing a bug, or adding a feature, maybe do some sort of unit test, right? If you're changing how your application actually starts up and boots, maybe that's an integration test. And if you're changing how your UI looks, maybe it's some sort of front end test like Selenium, right? So the right tool for the right job. So this is another complex topic, and putting one slide in here doesn't quite do this justice. But we've all dealt with legacy code, and I define legacy code as code without tests, right? So there's a few things you can do to help the situation, right? You could focus on writing tests in complex areas. You can try to spend a sprint or a few weeks just writing tests. I know that that idea sucks, and it's really hard to sell that to your manager, right? But the idea is once you have some tests in place, adding the next one is actually easier, right? So if you can't dedicate time to do that, maybe you make a pact that going forward you're writing tests for everything. So the next few bugs you fix actually takes a lot longer to fix that bug. Maybe that one line issue you found takes 8 hours to fix, right? Because you're spending 7.5 hours writing a test. Right? The next test might only take 6 hours to write, and then 4 hours. And then before you know it, eventually it'll be faster to write the test than not write the test, right? That's the goal. And of course, another option is to try to avoid that legacy code altogether, right? Is maybe there's an open source replacement you can use. Maybe you sort of wall it off with some sort of shim layer that's well tested, and your code only interacts with the shim. So at least your code can have a high degree of confidence it works. And so your legacy code is either updated or replaced. So we're just about out of time here. So I want to remind everyone that I think testing is confidence. That's why we do it. So if there's any questions, we can answer them now, or we can move to the track 2 Slack room.